Hello, this is Laura Castillo, and we are in week 7 of microbiology. In this week, we went over the sensitivity of antibiotics, and we conducted an experiment with the Kirby-Bauer diffusion testing. A couple of other things that we learned in this week's laboratory was some history on on antibiotics and the different types of antibiotics. For one, antibiotics can be considered what's called bacteriostatic or bactericidal. Bacteriostatic is when the antibiotic slows down or stops the bacterial from growing further, doesn't necessarily kill the bacteria. Bactericidal actually does kill the bacteria. And so one of the one antibiotic that's actually very popular and is considered bactericidal is penicillin. Penicillin actually does kill off other bacteria. And we learned a little bit on the history of penicillin and how in 1928 it was first discovered by Sir Alexander Fleming. He had some agar plates with bacterial colonies, and he had noticed that some mold had started to grow on these bacterial colonies, which killed the bacteria. Thus, this mold became known as Penicillium, which is a fungus, and from that we've developed penicillin, which is now very well-known antibiotic that's used all the time. So that's a little bit of history that we learned in this week's lab. As far as the actual lab itself, we did the Kirby-Bauer diffusion testing. In this test, we took a large agar plate. We spread the S. epidermis broth on there, let that absorb into the agar plate for a little bit. Then we got 3 little tiny discs, a gentamicin disc, penicillium disc, and novabiocin disc, and divided the agar plate into 3 sections, with each disc, and observed what's called a zone of inhibition. As you let this incubate, a white film will appear on the agar plate, and there's going to be a little circle around each disc, which is basically the area that the bacteria is being killed off or slowed down, depending on the type of antibiotic. So, in my lab this week, as far as my results, the novabiocin was the most effective with the largest zone of inhibition. The gentamicin was next. It was very close, but it was always also next. And the penicillin didn't have too much effect as far as with the S. epidermis. And it had the smallest zone of inhibition. One challenge actually that I did run into this week was I had taken a picture of my agar, which was kind of hard to see, but I could still see it, the zones of inhibition. But it was very, very light, but you could see them, just these little circles around the discs. And I had taken a picture, and then I had to go do something, and so I actually had to leave my lab in the middle, and after I had taken the photograph, and then when I came back to the lab, it had already been I think it was like another 24 hours actually, but when I went to put my lab photo into my actual lab report, I couldn't find the photo. I think I may have accidentally deleted it. I was in a hurry, so I'm not sure what could have happened there. But luckily I still had my agar plate. But the only thing that I found actually really interesting. So the only thing was that more bacteria had grown on it aside from the initial 24 hours I had already set. And so it's kind of hard to see the zones of inhibition. So on my lab report, I did kind of label them with dotted circles. But one thing that did have me thinking a little bit was that on the agar plate, the bacteria had started to develop colonies, even a little bit more around the gentamicin, the novabiocin, of course the penicillin, because that one didn't have much effect anyways. But I do wonder if this is an example of maybe of the drug resistance against the antibiotics. And so I don't know if that was the case in this particular lab, or if maybe it just somehow got contaminated with something else, but I thought that was very interesting. So anyway, this is also a really fun lab. I'm look forward to learning more about antibiotics. Hopefully, we can find some better solutions as far as the antibiotic resistance issue that's going on. Yeah, and that is all I have to say about this week's lab. Thanks.